Okay, so tangent. All right, graphing tangent. Let's see. There we go. So let's take a look at a graph of tangent here in our graphing calculators. So I'm just going to go to my y equals here. Okay, we're going to graph tangent of x. Oh. And you can see you get this like repeated kind of behavior. It's not really a wave, but it definitely repeats. And it looks like there's also some asymptotes in there, right? Looks like we have one like right in here, right in there, right in there, there, and there. Okay, and those repeat too. Okay, which kind of makes sense because we do know that tangent is undefined when cosine is 0. So for example, tangent of pi over 2, undefined. Tangent of 3 pi over 2, undefined. Okay, because both those places cosine is 0. Okay, so that'll give us those asymptotes there. All right, so we get a bit of a weird graph. Now, the good news about this like kind of weird graph, right, is that there's not a whole lot of like behavior for us to concern ourselves with, right? We have zeros, right, very clearly, like our graph crosses through the x-axis, you know, a bunch of different times there. But there's no like maximum value we need to find. There's no like minimum value we need to find, unlike those sine and cosine waves. So there's going to be fewer points that we need to kind of have on our graph, right? When we did sine and cosine, we always had to find the starting point of the period, the stopping point of the period, and then find the midpoint and then the quarter points, okay? When it comes to tangent, we're still going to find the starting point and the stopping point of the period. We're going to find the midpoint, but that's it. That's it. The midpoint of the period will be the 0, and then the quarter points, well, there's not really anything important there for us to kind of find, so we won't need to find those. So a little bit less work, thankfully. Okay, so all that being said here, let's kind of do an overview of the tangent function here. All right, so graphing tangent of x. Okay, so a few things we want to keep in mind here. The period length, okay, for tangent, or just straight up tangent, right, is going to be a pi. Not 2 pi. Tangent repeats every pi. Okay, and so then for our period calculation, and here's another difference. So that's one difference from sine and cosine. That initial period for sine and cosine, we always started from 0 and went out to 2 pi. Right? The period for tangent is actually going to start at negative pi over 2. We'll put that bx minus c still between, and then it's going to go to pi over 2. Okay? So it's tangent, the initial period for tangent starts at negative pi over 2 and goes to pi over 2. Okay? The range, okay, the range is pretty easy to decide here. If you look there, I mean, what's the range of that tangent look like it's going to be? What's the range is going to be there? From what to what? Or the range describes all the possible y values. So what does it look like based on that graph of tangent? What does it look like all the possible y values will be here? Yeah, so you see exactly right. Negative infinity to infinity. All real numbers. All real numbers, yeah. Right? Sine and cosine, we were limited to be just between negative 1 and 1. Tangent, it's all real numbers. The domain, I saved that one for, I want to do that second because that one's a bit trickier, right? So, for the domain here, okay, our starting and stopping points of our tangent graph, those are where our initial asymptotes are going to be. There will be an asymptote at negative pi over 2 for the regular tangent. There will be an asymptote at pi over 2, or wherever, you know, we end up solving for here. The starting and stopping point of our initial period there is going to be both asymptotes. Okay, they're both really asymptotes. There's no actual part of the graph there. So, with that being said, then the domain of tangent, again, just plain tangent, it's going to be all x values except, okay, except x equal to pi over 2, right? And you're like, okay, Mr. Wade, that's one of them, but clearly this repeats forever, right? So we can't say, whoop, I just turned it off. It repeats forever, right, to the left and to the right. So how are we supposed to know, how are we supposed to, like, say an infinite number of single points that don't occur? Well, here's how we fix that. We're going to take that pi over 2, we're going to add pi to it, right? Because again, I said it repeats every pi. And I'm going to put a pi k. Okay? And k is an integer, we'll say. Okay? So, since tangent repeats every pi, if I take pi over 2 and I add pi to it, that'll also be an asymptote. If I add another pi, now adding 2 pi, okay, that'll be another asymptote. Or add 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, so on and so forth. That's going to be our domain restrictions. They'll be all the asymptotes. That k value then, that's an integer. That takes care of the fact that, it's not going to be any, of any quantity of pi. It's going to be only integer multiples of pi. And it works in the other direction too, right? Because k being an integer, we could say we could subtract a pi. So plus negative pi or plus negative 2 pi. Again, going to the left there, that'll hit all of our different asymptotes that we're going to be concerned with. Okay. And so there's all that information. Now let's actually get into like how we're going to graph this thing, right? So let's go ahead and just do tangent. Let's go ahead and just do tangent, like the normal tangent function. Okay. So normal tangent function, right? There's no shift here, so we'll just start with a negative pi over 2 is less than or equal to x is less than pi over 2. So that's going to be our p. Okay. So when we go to do our graph, we want to make sure we include a little bit to the left. And we're going to again do two full periods. So let's see here. Negative pi over 2, I'll put it right there, I guess. And then there's 0, and then positive pi over 2, I'll put it right there. So that's one full period. That's our first kind of major full period there. But of course, we want to do 2 full periods. So what do I have to go out to? What's the next x like? What's the next period gonna? Where's the next period gonna end after this then? My first period goes from negative pi over 2 to pi over 2, and then it'll go from pi over 2 to what? Well, it's a length of pi, right? But since we're starting at pi over 2, I want to go pi out from pi over 2. So then where will I end up then? 3 pi over 2, exactly right. Yeah, the length needs to be pi, but to get out to that, I need to then end that second period at 3 pi over 2. So there's our first full period, it's a length of pi, and then there's our second full period, also a length of pi out. Okay? And again, for tangent, all you got to do is find the midpoints. Well, there's the midpoint right there for the first period. It's 0. The midpoint here, add them together. Pi over 2 plus 3 pi over 2 is 4 pi over 2, which is 2 pi. Half of that is pi. The good news is we really don't even need to talk about y values here. You could put like a 1, like a negative 1 in there if you want to. Oops, I guess I should have just kept that with my same color. Okay. And then all you do is just draw asymptotes. Asymptotes occur at those start of the period and the end of the period. So, okay, and again, the reason why we have asymptotes there is because tangent is undefined at negative pi over 2, which is really 3 pi over 2, right, coterminal to it. Tangent's undefined at pi over 2, right, also at 3 pi over 2 as well. Okay, so there are our asymptotes. And the midpoints are zeros, so 0 is a 0, pi is a 0. And then tangent's behavior, it just kind of goes up as we go from left to right. It almost looks like the shape of a cubic. Okay, just like that. And there's how we graph tangent. Okay, that's it. questions on any of that? We'll do one more. Yeah, Caleb?
You said it's for the period length,
Mm-hmm.
including negative values for
I guess that's true. Yes. Yes, I see what you're saying there. Yeah, okay. We can exclude it, I guess, if you want to there, yeah. When I'm describing the period, I see what you're saying there, yes. I guess we should exclude it, yes. That's true. We should exclude it. That's true, because it's not technically part of the domain. So same thing for there, okay? Same thing for there, too. So we don't want to include that negative pi over 2, because there's an asymptote there. It's not part of the domain. So that's a good point. Okay. We're all good with graphing this, getting the graph down, right? All good with that? We'll do one more, and then that's it, okay? Because I think it's, hopefully pretty straightforward at this point, okay? This next one we'll graph will be negative tangent. I'm just going to throw a couple things at you here. Negative tangent of x minus pi over 2 plus 1. Okay. All the stuff that we talked about with sine and cosine, right? So like period shift, period stretch, moving up and down, right? Okay, vertical shift, those things. And we don't really talk too much about an amplitude with tangent because, again, it's like there's no maximum minimum values. It just kind of makes it look stretched out a little bit, but doesn't really affect things. There is, something, the negative in front of the tangent will affect things more significantly there with our graph. So we want to make sure you get a little more accurate with that. So let's take a look at this here. All right. First, we want to take care of this x minus pi over 2. Again, here is where students, you want to really be careful. All right. Remember, our period for tangent, the starting period is negative pi over 2, and I almost made a mistake here, starting with 0. It's pi over 2, and then you put the x minus pi over 2 between, and then pi over 2. Okay. So that is one huge hurdle, right? We have to be careful with. Everything we've been doing so far has been 0 to 2 pi, 0 to 2 pi, 0 to 2 pi. Now we've got to be careful. Negative pi over 2 to pi over 2. Okay. So now we'll just solve here. So we'll add pi over 2 to both sides. You're going to get 0. And then pi over 2 plus pi over 2 is 2 pi over 2, which is then really just pi. Okay. And so then we'll go to, so we don't even need to worry about a negative part of our x-axis. So let's just go from 0 to pi. So 0 to pi, there it is. And then we'll go out, again, the period length here is pi, so we'll go out pi more to 2 pi. Really nice and easy calculations here. And of course, we want to find those midpoints. So it'll be pi over 2, and then 3 pi over 2 here. Okay. Sorry, I'm off the screen. There we go. And then we'll just draw our asymptotes. So starting at 0, asymptote at 0. Okay. Asymptote at pi. And then asymptote at 2 pi as well, because that's the end of the second period. Okay. Our zeros are at pi over 2 and at 3 pi over 2. Oh, but wait a minute. Mr. Wade forgot something here. What's that plus 1 going to do? What's that plus 1 do? It shifts up to 1. That's right. Shifts everything up 1. Okay, so here we go. I should have drawn this axis in as well. Shame on me. There we go. So that is where our zeros will be. We're shifting everything up 1, so pi over 2, the 0 would be here, but no, it's actually shifted up 1. Same thing here. Shifted up 1. Okay, so those are our zeros. The last thing we want to go to do now is draw in our tangent curve, okay? Now, normal tangent, right? Tangent of x, positive tangent of x. We start from the left and we go up and to the right, right? And up and to the right. Because it's negative now, though, what does that do? It's going to reflect it over the x-axis, or our axis here, and instead we go down and to the right, and down, and to the right there. Okay, and so there's our graph of tangents. And of course, the nice thing is when you have your graphing calculator, you can always graph it to check. And let me do zoom trig. If you guys didn't know this, by the way, on your calculator there's a command called zoom trig, which will actually adjust the x scale, so it's counting by pi over 2's, I believe. Yes, it's counting by pi over 2's. So there's our kind of section of the graph. There's pi over 2, and then there's 3 pi over 2 right there. So there's like the 0 and the pi, and there's pi and 2 pi right there. So it kind of makes it nice for the scale. And if you want, you can even like draw in the horizontal line y equals 1 and c. You know, so there's like pi over 2, and there it is. It's, you know, the 0 on the axis there, and then there's 3 pi over 2, and again it intersects there as well. You can kind of see that drawn in. Okay, so there it is. Questions on any of that? All right. So that's it. I'll give you guys your assignment then, and that's going to be it. We do have a small, let's see, hopefully a small assignment here. Oh, you know what? No homework. All right, so just work on that problem set. All right, just problem set for homework. That's it. It's a Thanksgiving miracle. There's no homework.